I'm going to demonstrate buffers. I'm going to use Connex to do so. Let me just kind of clear this away. All right. Let's start with, these are two different acids. The definition of an acid that we're going to use is just something that donates a proton or a hydrogen ion, and this green piece is what I'm going to use as my hydrogen ion. I know there's a lot of other different definitions of acids that are maybe appropriate in different ways, but this is the definition what we're going to use, is something that can donate a hydrogen ion. A base then will be for us something that can receive a hydrogen ion. Let's start with this. Let's just say that I have this particular acid. Let's say that this is a stronger acid. A strong acid is one that at any one period of time, most of them break apart, dissociate, the hydrogen ions are released into the solution. An acid that's not quite as strong would be one where maybe, I don't know, half of the molecules dissociate or break apart, and the other half don't. Now, these molecules, they're in equilibrium, and what that means is they're not just staying like this. I'll do this. These ones aren't just staying this way without a hydrogen ion, these ones with. No, these ones are breaking every once in a while, and for every time one of those breaks, another one of these forms. So we're just kind of doing that back and forth. This one maybe breaks apart, but then this one down here, these two collide and form. So we wind up with 1, 2, 3, 4 hydrogen ions in the solution. Now, what happens if we add a stronger acid to the mix? So let's say that right now we're in the blood, and this is a normal weak acid in the blood called carbonic acid. This is something called bicarbonate. So all that has to happen is there, boom, we just form some carbonic acid, boom, there we form some bicarbonate. But if, let's say we start anaerobically respirizing, meaning we're getting a lot of energy anaerobically, we're going to build up something that we've talked about in class. We've talked about lactic acid, and you've probably felt some of the effects of lactic acid if you've worked out anaerobically for a period of time. So let's call this lactic acid, and boom, right, as soon as it's made, it releases its hydrogen ion into the solution. Now, for other reasons, we don't have to talk about or worry about these guys right here. What we do have to worry about is the fact that now all of a sudden we've got 1, 2, 3, 4, 5, 6, 7, 8 hydrogen ions when we only had 4 before. So the hydrogen ion concentration has gone up, which means that our pH has gone down. That's how the pH scale works. What's nice about having buffers around is that if the hydrogen ion concentration goes up, there's going to be more collisions between these and these. So what's going to happen is we're going to wind up forming more carbonic acid. We're going to, get a little bit less bicarbonate, but in the process, what's going to happen is we're going to lower the concentration of hydrogen ions in the solution back to something that's 2, 3, 4, 5, pretty close to normal. So what we did here is we started with a certain pH. You know, your blood is fairly neutral, we'll say, and it contains these a mixture of carbonic acid and bicarbonate. When something else lowers the pH by dumping a bunch of hydrogen ions into the solution, those hydrogen ions can get picked up by the, we'll say, empty bicarbonate molecules to form more carbonic acid. But when you measure the pH of something, what you're really measuring is not the amount of the acid or the base in there. You're measuring the amount of hydrogen ions, or the concentration of hydrogen ions. And that, you can see, is pretty close to the original amount. In fact, I could make it right back down. I have that ability. Now, that's not very realistic. It's going to change the pH a little bit, because these are going to be breaking apart every once in a while and then reforming. But we've effectively buffered this solution. All right, I want to do that one more time here. Just going to kind of reset. I'll just do it in the reverse though. So we'll start off like I did last time. I'll have about 4 of these, and I'll have about 4 of these, and then that means I'll have about 4 of these. Now, what if something else comes along, some other process, I don't have to worry about what that is right now, and reduces the hydrogen ion concentration? Maybe leave one of those there. But something came and pulled hydrogen ions out of the solution. Well, now, because we have fewer hydrogen ions, our pH has gone up. And now what can happen is these guys are going to continue to break apart. But since there's fewer of these in the solution, there's going to be less collisions bringing them together. So these guys will continue to break apart to some degree, right? And, you know, there will be some, you know, okay, we'll break this, but then, you know, now we've increased the concentration, so this will happen now too. So what has happened is we have, again, brought the pH back to pretty close to its starting. We started with 4 of those green bars, and now I'm at 3, which is pretty darn close to what it was, because we had these guys that were able to break apart and establish a pretty close to normal pH. That's how buffers work.